Welcome. Welcome to the second workshop of the spoke on integrative AI within FAIR, the Future Artificial Intelligence Research national project funded by the Recovery Plan. FAIR has a, I would say, ambitious goal of fostering the future research in artificial intelligence. So I'm very pleased to introduce this workshop together with Paolo, Professor Paolo Giorgini at the University of Trento. And let me start with the partners. Fondazione Bruno Kessler, FBK, and the University of Trento are coordinating this project, with FBK involving various research centers, and as well the University of Trento engaging multiple departments, a very multidisciplinary department. Even more, we have engaged the two leading scientists in our partnership. Alessandro Sperduti, professor at the University of Padua, but now also director of the FBK Research Center in Augmented Intelligence, and Angelo Montanari, professor at the University of Udine, and a board member, but also the president, the chair of the scientific committee of the innovation ecosystem, INEST, of Northeast Italy. Even more, we have extended our partnership with the so-called cascade calls for university. No, let me say something before, sorry, I forgot. We have with us a very important industrial partner, Expert AI. Expert AI is an industrial partner of the FAIR consortia, but there is a specific reason why Expert AI is the industrial partner of our spoke, beyond a long-standing strategic collaboration we have with them. The core business of Expert AI has been AI, artificial intelligence, for the past 30 years. So it's not that they do AI now because it's trendy. They have a strong competence in AI. Second, they believe in our approach. They believe in integrative AI, hybrid AI, for instance, a combination of machine learning with knowledge-based reasoning, also because they have a strong experience in linguistic knowledge. Third, they focus on natural language understanding, natural language process. That is one of the main topics of our project. Then I was saying, this afternoon, there will be the talk by Filippo Nardelli, who is the managing director of Expert AI, and we will talk about hybrid AI and the market adoption of large language model. Even more, I was saying, we have through what is called the cascade fall for the university, we have now further partners with us that participated to this cascade code and won. The University of Bolzano, Padova, Udine, Torino, and Verona, with two different projects in two different departments. Tomorrow morning section will be dedicated to them, and they will present their project in FAIR. Okay, even more. This was the first bunch of calls, cascade calls that we had for university. Then we had further calls for private companies. And in the calls for private companies, we have extended our partnership with all these companies. There are 9 further companies with us. We have very interesting and innovative small, medium enterprise, and most of them are startups with a deep knowledge in AI, and also a large company like Reply that has a clear expertise in applying artificial intelligence to their business. This is very important because we have to remember that the goal of the recovery plan funding FAIR is to create an ecosystem, innovation ecosystem, where companies are more and more competitive in their business. So we strengthen the possible market impact of FAIR. Now a few words about our approach. We believe our underlying idea is that the future research in artificial intelligence will need more and more the integration of different techniques, like different representation techniques, different inference techniques, heterogeneous techniques. And this is not merely an engineering problem. This actually, rather, this integration requires novel theories and novel techniques that can really bring together different competence in diverse areas. And we aim at the integration, we pursue this integration along three main lines. The integration of models and techniques like neurosymbolic representation, or model-based inference combined with data-driven inference, but also, second, the integration across different areas of artificial intelligence. It's clear now how foundational models, integrating vision and language, give a great potentiality. But few years ago, and here we have the people working in LP and computer vision, these two areas were completely separated in some way. We aim at a further integration, so vision, yes, videos, images, text, but also speech and other kind of sensor, and also the integration of agents able to act and work and learn online, act online in an open-ended environment. Third, we have a lot to learn from fields that are traditionally not at the core of AI research, but that are closely related, like formal verification and validation that allows to build AI systems that are reliable, cognitive science that allow to build better agents that interact in a better way with humans, with people, because they have a mental model, mental status, they understand the cognitive capability of the person they have to interact with, and social science that allow to build agents that share and pursue a common community global objective of a society, not only an individual objective. Given these three lines, these three different lines of integration, we aim at providing an evidence that integrative AI can really advance the state of the art in modeling, learning, and inference in interaction with the environment inhabited by humans, and cooperation among multiple agents, artificial and humans. Now, given these two kinds of integration, given the three lines and the three challenges, we have organized our project along two different types of integration. Vertical integration, each work package, each task, each activity aims to integrate in some way, some form of different models and techniques across different areas of AI, also synergically with areas closely related to AI, and then horizontal integration that aim to cooperation between different tasks and work patches in order to address the three scientific challenges that I have just mentioned. So let me briefly mention how we have organized our project along to address the three main areas. For each of these challenges, we have work packages that are focused on this challenge, even if, of course, this separation is not sharp, it's not strict, because each task and activity has also to do with some way with the other challenge. But they have a focus. On addressing the modeling, learning, and inference, we have three work packages. The first work package on verification, synthesis, and autonomy leverages on our expertise in these fields to build reliable AI. The second work package aims at the tight integration of different models like neural, statistical, probabilistic, stochastic, logical, dynamic models, and to show that in this integrated model it's possible to do inference and learning. The third work package aims at the relation between models and the data acquired by this model. We have four work packages addressing the second challenge, the challenge of interaction. Multimodal perception aims at understanding and generating images and video. Natural language understanding and building reliable large language models also take into account the fact that they must be more inclusive, for instance, addressing the problem of biases, gender bias. Human-computer interaction aims at affect-aware and mixed initiative, interaction through mental models and theory of minds, and the embodied system work package ensures that these integrative models and inference and these integrative techniques can really work, can really function in a real-world environment with all the uncertainties that we know when you have to work in a real-world environment, in perception, in action. Then we have a work package dedicated to cooperative agents. Now, this work package aims at the vertical integration. Then we have work package 9 that fosters the horizontal integration that I explained between different tasks and work packages. Moreover, it fosters social and market impact through the instruments that we have in FAIR, like innovation grants, in the case, for instance, of the project of Expert AI, of open cascade calls that I have just mentioned. As I mentioned before, we are not only FBK and the University of Trento to work on this work package, but through the cascade calls we have engaged in our partners, important university. We have launched this call at the end of the first year, in December 2023, and we managed successfully to complete all the process, and I have also to thank the administration in this case, administration of FBK, of the hub, in complete the whole process means the evaluation, the selection, the contract signing by the beginning of spring. So in April, in March, most of the universities have started to work on different topics. The call was on 6 scientific objectives, each one dedicated to one work package that I have just mentioned, and here we have the winners of the university, and tomorrow morning section they will present their projects. Now, since this is the second work package, this is the second workshop of the spoke, the first workshop was at the end of the first year in December 2023, I believe it's important to mention the results and the focus of our project in the second year, in 2024. This focus is necessary because of 2 main reasons. One, because, as you know, every day, even last week, this technology is, in AI is really rapidly evolving. More than an evolution is a revolution. So we have to take into account this rapid revolution, let's say. Second, we have to focus on some area where we can provide significant scientific impact and contribution. The first focus was on integrative AI for multimodal foundational models, leveraging our experience in computer vision, natural language processing, speech recognition, and interaction. The second on AI agents embedded that have to work in an open-ended environment and have to act and to continuously learn in this environment, addressing the challenge of autonomous, interactive, and cooperative agents. And then we have been focusing on fostering the social and market impact through innovation grant, cascade calls, but also with collaboration with the public administration. Let's say a few words about the first focus. Integrative AI for multimodal model, we started to have some significant results in first in the topic of understanding and generating multimodal content from text to images and text to video with minimal supervision and in a reliable way. We have devised an unsupervised technique for bias detection, even of the bias that are difficult to detect, and also quantifying the impact of this bias. Then we have devised a training-free video anomaly detection technique and a task-agnostic vision language pruning technique that can eliminate unnecessary parameters without the need of retraining for a different task. We have devised an object-centric diffusion model that is able to control some desired properties of the structure and the appearance in an image and in a video. You know how much difficult it is to guarantee these properties. Then we have also focused on text and speech multimodal content. We have trained from scratch a truly open source, mounted open source, they say open science, open source speech foundational model. Truly open source is not open weight, like most of the large language models that are said to be open source. They are open weight. Also, they have available the data, they have available all the algorithms, all the techniques, the methodology for training from scratch this large language model from end-to-end speech recognition and translation. Then we have focused on two applications that I believe have a great potential for a market impact. Automated subtitling of films, of video, and simultaneous translation. Last but not least, we have focused on human-centered in the sense of providing translation that are gender neutral and identifying the gender bias and mitigating them. So just after our talk, we will have the talk by young researcher, very excellent young researcher like Davide, Marco, and Beatrice, that will explain this work and this slide much more in detail and with much more expertise than me, much better than me. Let me just show and highlight of some selected publications in this field that in the most important conference on computer vision and the most important conferences in natural language processing. That is an evidence of the scientific impact. I have also to say that this had an important impact in what are called transversal projects. You know that in FAIR, there are transversal projects that involve more spokes and foster the collaboration among spokes. All the results that I have just presented are important key contribution to the transversal project on vision, language, and multimodal change that involves our spokes, like spoke 1 in Pisa and spoke 5 in Rome. And then we are contributing also to the challenge of building large language models that are able to deal with audio, speech, images, and video, focusing on multimodal spatio-temporal and knowledge retrieval. And we are, with Bernardo, we are responsible for the work package on evaluation and benchmarking of large language models. Now let me focus quickly on the second focus, AI agents that have to work. We have first provided a logical foundation for system design. Today we will have Alessandro Cimatti that will show with this talk on deduction at work, how this can have a scientific but also an important impact for real application. And then we have also interesting result on probabilistic inference over hybrid domains, where you have both continuous and discrete variables and temporal satisfiability. And results on learning and decision making by cooperative agents in a social setting. Then, given this, we have devised a novel paradigm on planning and acting to learn. Most of the research in planning is about how to learn how to plan and act. Here, the paradigm is the other way around. So how to work in an unknown, on partially known environment, building agents that are able automatically to collect their own data to train their learning model, for instance, their neural networks. Even more, to understand the quality, evaluate autonomously the quality of the learning models and identify the situation in a given environment to have actions that bring the agent to collect the data such that the model can be corrected. This afternoon, other two young researchers that we have hired in FAIR, also excellent researchers, Tommaso and Leonardo, will talk about very recent research on learning the model on the environment. Tommaso about embodied compositional visual navigation, and Leonardo about learning a symbolic stochastic model, partial observable Markov decision problem, object-centric in a partially observable environment. Even they will explain all this much more clearly and much better, which one more expertise and much more in detail than me. Also in this case, we have a set of selected publications, top-level journals and conferences that are evidence the significant impact of this. Now a few words before leaving the word to Paolo about what we have done for fostering social and market impact. Already mentioned the innovation grant for partners in fairs of expert AI. Their project is called, has a very nice acronym, it's called RESPIRA, Replicability, Explainability and Reasoning. Our reference in our project is Bernardo, and it deals with a very interesting scientific problem that is the lack of reliability and reasoning capabilities of large language model. But it's really a market-driven project because managing directors and founders of expert AI say our clients, when we work with the insurance company, in the finance and medical application, they want the generation and the analysis of truly, that is reliable. And I believe also is a clear way to position Italian and European companies in this field of large language models. Then I already mentioned the calls for private companies, and this afternoon we will have a panel with all the speakers, all the people representing these companies, and explaining why, who they are and why they believe in their projects within FAIR. Then we have started to focus, for instance, the University of Trento and also FBK, in other projects that we have for digital health in real application on digital twins, for instance, in Trento and Bologna for dealing with the problem of tourism. Let me just finish with a few words about AI enactment, because I have to mention that our spoke is leading another transversal project that is the legal and ethical design of trustworthy AI system, is led by the University of Trento with Professor Carlo Casonato, that is for the faculty department of law. And what we are doing here from the point of view, I mean, beyond all the work on the AI Act, from the technical point of view, we are building a platform that is able to ensure that data, algorithms, and application comply with ethical requirements like having no bias from proper anonymization techniques. This is built on a more general platform that use MLOps and DevOps in order to develop application for the public administration, allowing for accountability and quality metrics. And the idea is to build a set of ethical assessment algorithms that allow for guaranteeing those kind of properties. Okay, now I would leave the short floor to Paolo about the KPI.
Thanks, Paolo. Thanks for leaving this very stimulating topic that is the KPI. So, first of all, let me start to say that to thank people that work on collecting the data, that it's amazing work, and analyzing the data. So, first of all, Zelene Tomassini from University of Trento and Chiara Fronza from FBK. And the second thing is just a reminder that tomorrow is the deadline for collecting the KPI, so your data for months 24, so don't forget the deadline. So, I think usually KPI are very boring, no? Very boring stuff, but actually give the picture of where we are and what we have to do for the end of the project. So, KPI in our project are organized by objective. So I will show you some graphs that give you the idea of what we have done so far at month 18, and actually what is still still missing, and what are the point in which we should work a bit more. So the first set of topics that are shown in this graph are about advancing frontier research. So this is more or less related to fundamental research. That is one of the most important objective of the project. And actually, so the green part is actually the KPI related to what we have done so far at month 18. The blue part is the target for month 18. So actually you can see that we already met the requirements, the target at month 18 for almost all of them. And actually you can see the orange part that represents the target for the end of the project. And interesting that we already reached the target for month 36 at the end of the project. for many of them. Actually, here we had some problem with at month 18 with a couple of KPI, are not so very critical. They are related to multidisciplinarity and research and innovation, but actually I'm really confident that we can actually do better for the rest of the project. So the second set of KPI regard reducing AI research fragmentation, fostering critical mass and inclusion. And also for this one, we are doing very well. So as you can see, the green part, it's overcome the blue and the orange for many of the KPI. A couple of KPI, we didn't achieve a couple of them, but actually are not really critical. So I think we should improve a bit on networking, in particular with the companies. But actually, this it's more related to the fact that the open call started. So the work of the partner involved with the open call started in March. So I think I'm confident that we will not have problems for the end of the project. So the third set of KPI regard creating human-centered, robust, and trustworthy and sustainable AI. Also for this one, we are doing quite well. So a bit less of the previous two one, but I think we are okay. Also in this case, we didn't reach two KPI. But are not so critical from my point of view. So the fourth one regard fostering AI-based innovation and development of AI technology. Also in this case, we are doing well with respect to the target of months 18. There is still some work to do for the end of the project, in particular on as I said before, on teaming for innovation. This it's related to the fact that companies are just involved in the last few months. And finally, the last two objectives are related to create, retain, and attract AI talent in Italy. For this one, we already reached the targets for month 36, so we are doing quite well. And we still have to work a bit on sustainability related to ensuring the long-term sustainability of the FAIR project. In this case, we have to do a bit more. So trying to summing up, so we are doing extremely well in terms of KPI. So the targets are almost reached for many of them. In particular, we already reached 30 out of 57 KPIs planned for months 36, so the end of the project. This is quite good. So this does not mean that we can stop to work, but actually there is we are doing very well. So for months 18, actually we reach 48 KPIs out of 57. So this means that there are some critical KPI that we should pay the attention, that include the number of European projects with partners of the FAIR project. I think this is quite normal because we are in the half of the project, and actually we start to work together, and actually the European project usually take time for propose a project to be approved and so on. We have to work a bit more on writing white and position papers on topics related to the spoke. So I think this is not a big issue, comparing also with the amount of the papers that we already have. It's just a matter of do some work on that. The numbers also of papers published on magazine for general public. I think this is not difficult to reach. It's just a matter of proposing some of our activities to the general public, including also the activity that we do with the companies. The other two also, it's not a big issue, are related to a number of early stage research working in collaboration with industry. I think also this one will come up, will be reached when we have this collaboration with the companies that are involved in the project. And finally, we have this final KPI that we didn't meet. This on benchmark data set on robust and trustworthy AI and on green and sustainable AI. So I think in general, so the message is we are doing quite well. Most of the KPIs for the end of project are already met, so it's just a matter of fixing some of the KPI, but I think we are quite good. So thank you.
Okay, thank you very much. We didn't program any question for this, but I would say while Bernardo, that is the chair of the next session, and yes, and the first speakers come, if you have some question, we can answer. Paul and I can answer to the question. But I would encourage Bernardo and the first speaker to come and join and prepare the presentation. Usually the introduction are very boring, so there are no questions, okay?
Okay, so Marco, you can try. We can start the first session of this workshop. The session is dedicated to multimodal foundation models, which is one of the important topics of our spoke. We have two presentations given by young researchers, as Paolo mentioned. For each presentation, we have 20 minutes, followed by 10 minutes for questions. So the first speaker is Marco Gaido, and he's going to talk about towards the creation of an open source speech foundation model. Thank you, Marco.
Thank you. Thank you, Bernardo. So today I'm presenting this work towards the creation of an open source speech foundation model that has been carried out by two units here in FBK, the speech tech unit and the machine translation unit, which I'm part of. So our goal in this project was quite ambitious, to bring Italy at the state of the art in speech processing. And the way to do this for us was to build state-of-the-art models for Italian speech processing and make them available to everyone, and to share this knowledge on how to build the state-of-the-art models with everyone within the nation. So the way we wanted to achieve this is to create an open source Italian speech foundation model, and we'll see in this presentation why this enables us to meet this goal. So let's start from the definition of open source. Open source is something that comes from the software engineering. There is the open source initiative, which basically says what open source means, and basically open source is defined by 4 freedoms. The freedom to use the system for any purpose. So a system to be open source has to be usable by everyone. Everyone has to be able to study how the system works, to modify how the system works, and to share the system with others, with or without modification. So this enables everyone to start from a software in this case, and to do whatever they want with this software. In the case of AI, this is not directly applicable, so the open source initiative created a model openness framework, a new definition of what open source AI is. And this definition has created 3 levels of increasing openness. And in this work, we focused on the most strict level, the open science level. So we will always talk about open science later in this talk. And what open science means is that all the three components that are used to create and are critical for the creation of an AI system have to be available open source. So with all the four freedoms that we have seen before. And these three components are the data, the code used to build the model, and the model itself. So everything has to be available to everyone, and this ensures that in terms of our goal to share the knowledge on how to build this system, this ensures that everyone has all the bricks that need to recreate and redo and replicate what we have done. So our roadmap to achieve this is made of two steps. First of all, we have to collect open source speech data to train our model, and then we have to build our Italian speech foundation model. So far, we're done with the first activity, and we are going on with the second one. So let's start from the first part, the open source speech data that we address by releasing Mosel that was presented at EMNLP, a top-tier conference in NLP last year. And Mosel is a collection of open source compliant speech datasets that covers all the European Union languages. And we have both speech data with the corresponding transcription, and there was also speech data without transcription, and we created pseudo labels for that, so automatic transcriptions that were also released under an open source compliant license. Mosel comprises 18 datasets that, as I said, cover all the official European languages, and out of these 18 datasets, 3 were unlabeled, while 15 had the transcripts. And in total, we collected nearly 1 million hours of speech data, covering all the languages. Focusing only on the data with real transcription annotated by humans, we can see that they are roughly 500,000, but they are very skewed toward English. So basically, most of the transcriptions we have, most of the data we have with transcriptions are English data. And this makes unlabeled data very important and critical, because if we want to support other languages, and Italian is among them, we really need unlabeled data, which in Mosel are, again, nearly 500,000. And in this case, the distribution is less skewed towards English, so we have more data also for the other languages. For the creation of the pseudo labels, as I said, we created the automatic transcription for nearly all the data that didn't have them in Mosel, and we did them with Whisper Large v3, which is a model released by OpenAI, which is open weight, so not open science, but open weight, and supports many languages, including all the European languages. And the cost of this activity was quite high, not only in terms of human effort, but also in terms of computational cost. And an estimate of what this means in economical values on if we were using cloud resources is more than 100,000 euros. As I said, all the automatic transcription that we created are available under an open source compliant license, which is the CCC BY 4.0. Mosel 1.0 is already released, as I said. This was a work presented last year, and everything is available for everyone, so if you want to play with it, you can do that. Here you have the QR code to access the collection of the datasets we created on GitHub, and also the automatic transcriptions that were released on Hugging Face. In these 3 months, since Mosel has been released, we have had more than 8,000 downloads and 200 stars among GitHub and Hugging Face. Then, once we have collected the data, the next step is, of course, to create the Open Science Italian Speech Foundation model that we named FAMA. So, although this is work in progress, there were some aspects that were already published at ACL, that is a top-tier conference. And first of all, we focused on the software, because also the software that we use to create our model has to be open source, as we have seen. And in particular, besides the open sourceness of the software, what was important for us was also software quality. But software quality, yeah, the question is what it means. And for us, software quality is defined by software quality assurance, which is a software engineering field that defines many properties of a software that have to be ensured. And some of them are very critical for us, in particular the usability of the software, which means how easy it is for another person to use our software. And this is very important for our goal of sharing knowledge on how to build these models. But there are also other aspects that are critical also for us in our operational activity, which are the reliability of our software, because we don't want that our software crashes every second day, since already the trainings are quite long. And also the efficiency of our software, because again, trainings are already quite long. We'll see some numbers later. So if our code is inefficient, this would take even much longer. And also the correctness of our code, which is not so given for granted, I can tell, especially in the research community. So how do we implement the software quality assurance? We have two pillars. First of all, we are following SQA best practices in our daily activities. This includes creating unit tests for everything we do and having continuous integration, so we ensure that everything we do will still work and we will not break it. And also we released an open source library dedicated to create unit tests for deep learning architectures. And this is what we are using to enforce that all our architectures function properly. In terms of model, we are using an autoregressive model, an encoder-decoder autoregressive model. On the encoder side, we are using a conformer encoder, and on the decoder side, we're using a transformer decoder. This means that what happens is we take the audio containing some speech, we pass it to the conformer encoder. The conformer encoder creates an high-level representation of this audio, which is convenient for the neural network. And then the transformer decoder takes this high-level representation created by the encoder, takes the words that have been predicted so far, and it predicts the new word in an autoregressive manner, which means exactly this. So we iteratively predict the next word. In this case, we have the audio that comes in, we have the encoder output, we feed it to the decoder, we feed also this as first word, and we predict this. Then we feed the transformer decoder with this, and we predict the, and then we have the same with this is the, and the transformer decoder predicts audio. In the design of our model, there were three aspects that we focused on. First of all, since we are Italian researchers working for Italy, let's say, we wanted to focus on Italian. This means that for the training of the model, we selected only Italian and English data, and we are focusing on the recognition of Italian and speech data and on the translation from Italian into English and from English into Italian. As a second aspect, we focused on efficiency, because to be able to use these models, it's very important that they respond promptly. We don't want a very large model that takes hours to give an answer. So efficiency was another key aspect for us. And since we have seen that we go through the encoder only once, but we go through the decoder many, many times when we are predicting something in our model, this translated into the design choice of choosing of having a very deep encoder, a big encoder, and a small decoder. So we ensure that the part that we iterate on is faster. And last, we want our model, we want to be able to integrate in a very effective manner our model into large language models. So we want to be able to expand the capabilities of the speech foundation model we create with the abilities of large language models that nowadays are present everywhere. And we have also instances of large language models specifically targeting Italian. And since this integration happens following the schema that, I won't go into the details, but what is important for us is that for the speech foundation models, we only take the encoder. So we only take the speech encoder, we throw away the decoder because we let the large language model to do the part of the decoder. So again, to be able to exploit effectively our model, it's important that our model has a very big encoder, a deep encoder, and a small decoder. So we throw away only a small fraction of our model when we integrate it with the large language model, and we retain most of its capabilities. To give some numbers, we are creating two sizes of our FAMA model. A small version which has 480 million parameters, and a medium version which has 880 million parameters. And as I said, we are targeting two tasks: the automatic speech recognition, which means being able to transcribe an audio in the same language, and speech translation, which means the ability of translating from speech uttered in one language, for instance, I'm speaking English, and translate directly into text in a different language. For instance, in this case, we can translate what I'm saying in Italian. Regarding the data, we took 150,000 hours of speech data from Mosel, and out of them, 128,000 hours are English, and 24,000 hours are Italian speech. In terms of cost, again, the costs for building this model are not few. Also computationally, it's also quite computationally expensive. And building FAMA would not have been possible without the collaboration with Cineca that is providing us the resources to do this. And in terms of storage, only storing these 150,000 hours takes more than 25 terabytes of data, of space, of disk space, which is not few. And in terms of training time, these are more or less the numbers of complete training of the small and medium models. This is an estimate. This is not what has been the truth, because this is the ideal time. If everything works well, you never have problems, and everything works smoothly, and there are no failed attempts, there are no preliminary experiments, and everything. So we estimated roughly what would be the cost of building FAMA on cloud like AWS or Azure, and this would be more than 300,000 euros. So, comparing with state-of-the-art models, because as I said at the beginning, we want to bring Italy at the state-of-the-art, so we want our model to be state-of-the-art model. Comparing with other models that are available, we have the Whisper from OpenAI, that is maybe an open model in terms of open sourceness. We can debate on that. It's not clear. But we have two sizes of Whisper, the medium and the large. The medium is a bit smaller than our medium, but the large is nearly 2 times it. And it supports 99 languages. Also, we have Awesome, which is an effort from CMU, the Carnegie Mellon University, that in terms of data size is close to us, even though it targets 151 languages. And it's also providing a medium version, which is slightly bigger than our model. So for FAMA, we are targeting only 2 languages, but as I say, we have more or less the same data of Awesome that includes 151. And as you can see, FAMA out of this is the only one which respects the open science, all the open science principles. Regarding benchmarking, I have the results only for ASR, so automatic speech recognition. For speech translation, we don't have yet, because as I said, we are work in progress, so we don't have yet the version of FAMA that includes also speech translation. We are creating it. We are also finishing the training of the medium version of FAMA with ASR, so the results for it are partial. And as we can see, we are more or less on par with Whisper. Our medium version of FAMA is more or less on par with Whisper. It has a slightly higher word error rate on English, but slightly lower on Italian. And our small is also competitive in English with most of the others, including Awesome. And in Italian is the second best after Whisper and our medium version of FAMA. Also, Meanwhile, we are creating FAMA, and we also worked on how to use speech foundation, on creating application of speech foundation models for real-world use cases. So we published these works at ACL last year, and we have basically created a suite of techniques that we can use to leverage speech foundation model to target real use cases. Among these use cases, one is direct subtitling, for which we created a technique that we named SBAM. In direct subtitling, what is special is that when the source audio not only has to be translated into a different language, into text in a different language, but we also need to assign timestamps to these translations, and we also need to segment this translation into different blocks and blocks into lines. Because when we are watching subtitles, we are used to see 2 lines of text, more or less, and we want the subtitle to be displayed when the same thing is said by in the video. So these 2 aspects are covered by this method that leverages speech foundation models. And then another aspect we work on is simultaneous speech translation with the Stringa technology. And this method enables us to translate a continuous and unbounded speech, because most of the times in research we focus on a very easy scenario in which we have audio already split into small sentences, and we just need to translate these small segments. But speech doesn't work like that. In speech, like in this presentation, there is a continuous flow of the audio, which goes on maybe for minutes, hours, and so on. So we don't have small pieces of most pieces of audio. So we created this methodology that leverages a speech foundation model like FAMA and is able to translate a continuous flow of audio in real time. So to summarize, our goal in this project is to create an Italian open source speech foundation models, but rather than open source, we can say an open science speech foundation models, and we have seen what this means. As a first step, we created Mosel, which features more than, nearly 1 million hours of speech data, covering all the 24 official European languages. We also created solutions to apply speech foundation models for real use cases. And lastly, we are building FAMA. And although this is in progress, we hope that will be done soon. And we will release our open science English-Italian speech foundation model. Thanks for your attention.
Marco, very interesting presentation. We have time for questions. Any question? No.
Thank you for your presentation. What was the most challenging part in, what have you learned, if you have to think when you started and now, and also what is going to be any improvement? Do you have a strategy for thinking about improvement? It's just increasing the data set, or there is also some architectural feature that you think would help in increasing the performance?
Thanks for the question. So one of the most critical aspects that we are still struggling with is that training such large-scale models is very different from what we have done so far, working with smaller models. And here, resources is a very critical thing. So one thing that is critical, for instance, is the RAM available. And if we want to scale further, the dataset size, for instance, we'll need to rethink a bit our code to restructure it a bit, because it won't scale otherwise. So there are many things that you don't think are critical. For instance, how you load the data. Currently, the way we are loading the data is not so RAM efficient, and if we want to scale to other hours, we need to rework a bit that. Yeah, so most of the problems are in terms of efficiency. So if we want to scale the model and the data, yeah, we will need to work a bit to have a large version of FAM. This is something we are thinking of. Yeah, but it depends on many things, also on the resources that we will have.
So basically technological problems, they are not methodological, there is no problem with the architecture of the model.
Yeah, regarding the architecture and the model, maybe the most critical part is the efficiency. Because when you scale to these models, it becomes a concern. So there are solutions that we haven't tested in FAMA so far to make the model faster at inference time. Yeah, but that's something we already worked on and we will work on. The problem is, again, that doing a test is very expensive, so it's not always easy to search, to cover all the search space, right? So.
Okay, thank you.
Other questions? Paolo?
Okay, my question is about, thank you very much. My question is about subtitling. How do you ensure some constraint? For instance, I think in subtitle of movies or films that you have limited length, or even sometimes this is done so you don't have really to transcribe or translate exactly. How do you ensure this?
The answer is simple. We are not ensuring it. We are not ensuring it. What we have seen is that compliance of these requirements is also not always obtained with industrial applications. So most of the industrial subtitling systems fail to comply with these subtitling constraints many times. So far, yeah, we haven't done anything specific for that. We focused only on creating a subtitle that is coherent in terms of time with what has been said, and that respects the total number of lines. So we don't want to split a subtitle into more than 2 lines. But we didn't focus too much on what you.
Those are already constraints.
Yes, but.
Timing. I've seen also translation where it's not synchronized. It's there.
Yeah. No, but that's something we have to work on. Thanks.
Okay, so I think I have one question. It's about the content of the data you have been collecting. So when we train large language model, the content is a relevant issue. You need to preserve some distributions across different domains, genre. You have to consider the kind of data you have in terms of biases that they might contain. So I was wondering whether you have any of these issues when you collect data for speech foundation model.
Yeah, we do have. And there isn't much we can do because there isn't much speech data available under open source licenses. So we basically collected everything we could. But yeah, we do have biases. For instance, the male speakers are much more than the female speakers, and in terms of domains, we have a lot of data that comes from data sets that are read speech, like common voice or multilingual libre speech. But we also have a lot of data that contains conversations, like Vox Populi, where there are the European Parliament debates. So I think we are good in terms of different accents, for instance. What we are not good is the gender balance, that's for sure.
Okay. So I noticed that part of the data come from YouTube, so from video on YouTube. I was wondering whether for those data you have any issue about content again in terms of potential violations of privacy of people?
Well,
how do you have any?
We collected only videos that were released under the CC BY license. So this means that the author only wants to be attributed for the content. So we are respecting their what they wanted to be respected in terms of licensing. We are not de-anonymizing the data during the training, but in our case it's not so critical because we do have techniques to make the speech that we use kind of speaker independent. So we have a technique for that. And also we are not producing raw speech. We only produce text. So we are basically not producing any voice of any speaker.
Okay. Thank you very much. Paola, are we in time or?
Yeah, perfect time. So.
Perfect time. So thank you very much, Marco. So now I invite Davide Tolon to check the computer. So this is the second presentation for this session. It's about multimodal perception. Again, a very important topic of the project. Okay. Thank you very much, Marco. Davide.
So, good morning, everyone. I'm Davide Talon, and I'm from Fondazione Bruno Kessler, and I'm here to present our investigations under Work Package 2.4 on multimodal perception. And I'm here to present the advancements on behalf of Niku Seben and Elisa Rizzi, so the joint effort of University of Trento and Fondazione Bruno Kessler. Okay. So let me give you an overview of the research topics that we investigated. In particular, so here we're focusing on Work Package 2.4, and we care about developing new paradigms and architectures for multimodal content generation and understanding under task 2.4.1, learning under shift, that might be domain shift or semantic shift under task 2.4.1, and finally we care about research-aware cross-modal deep architecture under task T2.4.3. But let me stress that there are some shared connection with Transversal Project 2, which is aiming to build an Italian multimodal model, and we care about mainly about trustworthiness of AI. So today I'm going to present a few research activities that we presented at CVPR 24, which is the premier conference in computer vision, and I will be talking about image editing, so in the context of generative models. I will be talking about video understanding with vision language models. In particular, we're talking about video anomaly detection. I will introduce you to test time adaptation, so when we have shifts in our inference data in the context of activity recognition, and I will briefly mention bias detection for generative models, and finally we will talk about efficiency of vision language models by using pruning. So let's start with multimodal generative models, in particular with image editing. So what we tried to do in this work is to define an image as a composition of different objects, where in order to have the possibility to modify specifically, so have a fine-grained capability to modify the image by object-wise. So the idea is that we have a composition of objects in an image, and each object is represented by its structural information. So like where it's located in the image and its shape. And then we have the appearance information, which is provide information on the texture, the color, the lighting, and so on. And by simply either modifying the structural information, so the class or the position in the image or the appearance information, we're able to perform different editing tasks, as could be editing the shape, editing the appearance, or add new objects into the scene, or having different variations about the original image. And we rely on foundation models in order to have the generation. So we condition foundation models, generative foundation models, in order to have the generated images. So let me give you a few results. Also here we are looking at the results for the additional objects introduced to the scene. So for instance, suppose we have this nice park here in New York, and we want to add this cute dog. So by providing the structural information where it should be located in the park, and providing the appearance information by using a driver image, we're able to insert the new dog, the cute dog in the park. And similarly for the flowers in the garden of the house, the carpet in the room here, or the cake on the table. So we provide structural information by specifying a layout mask, and we provide appearance information by using a driver image. Similarly, for the editing pipeline, we can use the same architecture in order to perform editing of the appearance of specific objects. So by specifying through a mask, by specifying the objects of interest, and by specifying the appearance of that we want, we are able to get the objects with the new appearance. So here we have Hulk that is able to talk with Iron Man. And similarly for the snow, here we can have the appearance of the lava and the purple sky, or the sport image here. So let's move on. So let's talk about video understanding with vision language models, and in particular to the task of video anomaly detection. So the idea of video anomaly detection is that we have a footage, so we have a recorded video, and we want to both classify what's happening in the video, something that is strange, something that is different from regular actions that could happen in the video, and we want to localize it in the time frame. So for instance, here we have the video, the recording of a control room where some maintenance is going on, and we want to be able to detect whether there's an explosion or not, as is happening here in this footage, and we want to localize. So we want to say, okay, at this timestamp, we have the explosion happening, and this is what we're looking for. So let me try to frame this work in the literature. So previous work were mainly based on training techniques. So whether they were relying on some level of supervision, so there were fully supervised approaches which were labeling all the different frames of videos. One class only that were relying only on regular videos. Weekly supervised learning, where we were saying, hey, there's an anomaly in this video, or finally there was unsupervised learning. But the real problem behind training is that we are imposing, we are constraining, we are enforcing some priors in the kind of anomalies that we are able to deal with. And this is limiting even the domain on which we can apply our strategy. So the idea is that we can rely on foundational models and to have this information, to be able to generalize to different settings. So we rely on large vision language models that are available to the community, and the implicit knowledge provided by large language models about what an anomaly is. And so we are able to apply our strategy to different contexts. So let me try to give you an overview of what the strategy, how we implemented this strategy. So at the beginning, we have the footage, and we use a captioning model in order to provide this textual description of what is going on in the video. And after some cleaning, we have that the large language model is providing a score about whether there's an anomaly or not going on in our video. And after some other cleaning, in order to smoothen the prediction, we are able to detect the anomaly in the video, both in the time frame, and we are able to provide a description of what is going on. So for instance, here we are able to see that nothing really is happening in the Hawking Act, but you know they are fighting quite a lot. So let's move on under learning under some shift, and let's talk about temporal action localization. So the idea of temporal action localization is that we want to classify the actions in the videos, and we want to localize in the timeline. So let me stress what we try to do here. So the idea is that current approaches in the literature are mainly based on training. So we assume to have labeled data, and these models that are trained are later applied to at inference time to new data. So, but what happens if we have different data with respect to what we have seen during training? And as before, since we are doing training, we are enforcing some prior on the kind of actions and domains that we are able to deal with. So what about using some foundation models, which we all know have a strong generalization capabilities in order to avoid having this shift? But we can do better. So we can improve at inference time, we can improve the knowledge of the foundation models in order to get better performance. So a brief overview of the strategy. So at the beginning, we start from global information about the video as gathered from the entire video, and we compute a pseudo label of what is going on. So we try to predict what's the action that we care about in the video. And after some contrastive like optimization, where we try to separate the frames associated to the action of interest with respect to other frames, we are able to localize the actions in the time. And after some filtering here, some suppression of noisy sliding windows, we are able to localize the videos, and we can rely on a pseudo label in order to classify the different actions that are going on in our video. So here, is tennis period, so we have a tennis swing as our action. Let me move to Trustworthy AI, which is connected to the Transversal project too. Here I wanted to present a well-known bias that we have in generative models. So this is given by Stable Diffusions. If we ask for a picture of a doctor, we have that most of the time the pictures that we generate are gender biased. So they have males, right? But what happens with on biases that we do not know about, so that are understudied? So is there any way we can focus on try to study new biases? So that's the idea behind this work, which is trying to study new biases on generative models. So in the literature, what is done is mainly we have a predefined set of biases, so biases that we define as humans, and we have a model which is trained, so which is trying to classify whether the bias is present or not. But the idea that we have is that we wanted to move into an open set setting where we do not define the biases a priori, but we try to find new ones. And our only assumption, our only prior is that we have some captions. So we have some caption available in order to understand what biases might be present or not in the data. So a brief overview of the strategy. So here, what we are trying to do, so we start from the captions that are our only source of prior in order to detect the biases, and we feed the caption into a large language model. So we exploit the implicit information provided by a large language model in order to ask what are the biases that might happen with these captions. And we do that, so we ask for the name of the biases. So for instance, a name of a bias might be person gender, and we ask for some categories of the person gender bias. So for instance, might be male or female. And finally, we ask the large language model to provide some questions in order that we can later use in order to detect the bias in the generated data. After this first step, we have a second step, which is the generative step. So starting from a generative model, we feed the captions that we had in input at the beginning to a generative model in order to provide the generated images. And afterwards, we use a VQA strategy, so a visual question answering strategy, in order to quantify the extent of the biases in our data. And we can later use this information in order to, trying to reduce this bias in the in a feedback loop in order to reduce the bias in the generative model. Okay, here are some results, so new biases that we discovered on latest generative models. And for instance, if we ask for a traffic officer, most of the time we have a bias on the gender of the traffic officer. So most of the time, I hope you can see, we have that the traffic officer is a man. Something quite funny is that if we ask for a train zipping down, we have that the train is mainly yellow, or it might have some blue patches. So this is a weird bias, I would say. Another interesting bias is the laptop brand. So if we ask for someone working by using a laptop in a coffee shop, we have that most of the time the laptop that is visualized is a well-known brand, so like a luxury brand. Finally, we observed some biases in the breed of the horse when we ask for a cop riding a horse. So as you can see, most of the time we have that the horse has the same brownish fur and is quite muscular. Okay, let's move on. Our final project. Our final project we presented at CVPR 24 is on resource-aware vision language models. So in the literature, most of the time when they try to reduce the computational demand of vision language models, they perform pruning, and the pruning that is performed is task specific. So starting from a vision language model, I need to prune the weights that are they are not really relevant based on some kind of feedback provided by the task that we want to perform. So the problem here is that, first of all, I need to start the pruning procedure every time I have a new downstream task. And the second problem is that it requires to have the original weights of the vision language model, which, might be critical for resource-constrained devices. And let me stress that, since we are dealing with a foundation models, I would say it's a quite strong assumption to have a specific task, because foundation models are definitions, they should be applied to different tasks. So the strategy that we try to develop with this work is to have a task-agnostic pruning of the weights. So starting from a dense vision language models, we have one single pruning procedure, so we prune only once, and we are able to deal with multiple downstream tasks, as could be captioning, retrieval, or VQA. So brief overview of the strategy here. So we start from a dense vision language model, and we try to understand the relevance of the different ways by relying on the original foundation model that we had at the beginning. And to do that, we rely on a small data set that is used for calibration, and we evaluate the information flow, how the information flows in the network by considering the amount of information that is provided in input to a weight, the amount of information that is output of the weight, or the amount or the magnitude of the weight itself. So we estimate the information flow based on these three properties of the weight. But the naive use of this information flow would lead to over-pruning of specific part of the network, because first, there are some differences in the modalities, and second, we have that different layers should be pruned in different ways. So in order to account for these differences, we try to reweight the pruning, the fraction of pruning, based on the weights of the original model that we had at the beginning. So, okay, let me wrap up this presentation with the plans and future work. So the plan for the next year is to try to keep working on video understanding and specifically with language, which is the new thing in our community. And an example here might be content-based video retrieval, which is still not really working. A second research direction might be personalization and adaptation of vision language models. And finally, keep working on trustworthy AI, especially on unsupervised bias identification and unlearning, so removing personal concept in large vision language models. So that's all from my side, and thank you for the attention, and if you have any questions, I'm glad to answer.
Thank you very much, Davide. So we have time for discussion. Paolo.
Thanks for the presentation, very interesting. One question about the level of granularity that you can reach in anomaly detection. So can you elaborate a bit more? Because actually from the picture seems that,
initially we use a captioning strategy, so we are able, we are able to get the main properties of the scene, and on specific anomalies, instead we are relying on the implicit knowledge of vision of large language models. So specifically, we prompt the large language models to simulate to be an officer and try to detect whether something's wrong in the video. So we don't really have a way to specify the granularity, but that's a nice direction, of course, for research.
Any other question?
Thank you. Just a curiosity, because I'm pretty confident with large language model and whatever is related to language, but less confident with video-related models. So I was curious about if you can spend some words more about how do you proceed with video embeddings? Because with images embeddings, when using a transformer, it's pretty clear you apply some patches, and each patch has an embedding. But in video embedding, how do you do that? You concatenate several patches in sequence. So just curious about that. If you can spend some words more about how do you embed in this video context.
Okay, so first of all, these works were in the initial phase of the video, when they try to address the videos. So here we are working frame by frame. So we use an image vision language model in order to caption the different frames. And then we gather the information, so the different embeddings or the different captions. But from what I've seen in the literature, what they're trying to do is what you said. So they're trying to concatenate different frames, and they provide them to a vision language model, regular vision language model, in the most naive way. Thanks.
Okay. I think I have a question. It's about, again, integration of large language models for video understanding. So maybe you can elaborate a bit more about whether you need or not fine-tuning of the large language model on a specific task, or whether this is zero shot. And another issue is balancing the role of the visual model and the language model in such kind of applications.
Okay, so here we are working zero shot. So we don't have any training, we don't have any gradient flowing. And that's the peculiarity of the model. So we are not enforcing any prior into the anomalies that we can detect. And but fine-tuning, of course, might be an option in order to improve the performance on a specific set of anomalies that we can have. And on the second question instead, so far what we are doing, we are providing textual description about the frames to a large language model, which is later trying to, by using its information about what an anomaly is. It's trying to detect whether an anomaly is present. And the critical part is that there might be some information, since the large language model is lacking the visual part, there might be some information that is not provided by the vision language model.
Exactly.
So that's the critical part. This is what we observe to be, the challenge there. But I mean, since the pipeline is quite modular, we can easily improve the vision language part in order to provide more refined captions, improved captions, and to have a better description to the large language model.
So richer captions.
Richer captions, in practice.
Okay.
Yes, that's the challenge there.
Okay, thank you very much.
But let me stress that even temporal consistency can be improved, because so far we are working on a frame-by-frame level. So working on videos directly might be helpful.
Okay, thank you. Paolo?
Thank you very much. At the beginning you mentioned editing, inserting or changing some properties. You didn't have any example with deleting something. And also I was wondering whether you've done some work on using natural language, for instance, for doing this kind of editing. Like I found it very difficult to tell, for instance, to GPT-O, I want the same image, but without that object in the image.
For sure is a task that is addressed in the literature, so a classic in painting where we're trying to remove. We didn't test with removal of objects, but conceptually the module, the architecture, the algorithm can easily work with the removal of objects. Because the way we define a picture is a simple list of objects. So where each object is structural information and appearance information. So by simply removing one of these objects in the list, we can remove objects. So in theory, it's possible. We didn't test, but I mean, we can provide some qualitatives about that.
Natural language to say, please give me the same picture without that object.
I mean, language models, I'm a vision guy, so I'm not really confident there, but like language models are struggling with negation, right? So we have this problem, and this is the challenge, and even for vision language models, which are somehow having a language model in the middle, are lacking this information. So like usually here we exploit clip representations, where we try to to pair image and text, but since these models are not trained with this negation, it would be quite challenging at this point, at least. But it's something that they are trying to address in this period. So thank you for the question.
Just by curiosity, which language models are you using?
I mean, we use open source in the literature, so we mainly rely on Llama or Phi 3 or 4.
Thank you. Time for the last question in case. If not, we thanks again.
Thank you all.
Davide, thank you very much. So the session is concluded. Now we have half an hour, right, for coffee break. And discussion. And discussion. Okay, and discussion. Thank you.